Today on STEM Perlu, we'll look at one-digit divisibility rules. Divisibility describes when a positive integer divides into another number evenly. For example, 12 is divisible by 3 because 12/3 is a whole number. A divisibility rule is one where the numbers that are divisible by a number form a pattern. As an example, to determine if 12/3 is an integer, we apply the divisibility rule for 3 on 12. Let's start with divisibility by 2. A number is divisible by 2 if it ends in 2, 4, 6, 8, or 0. The numbers 8, 22, 34, and 108 are all divisible by 2 because they all end in 2, 4, 6, 8, or 0. Note we only count the digits all the way on the right for this divisibility rule. None of the numbers 5, 23, 107, and 255 are divisible by 2 because each of them does not end in 2, 4, 6, 8, or 0. Now let's cover divisibility by 3. A number is divisible by 3 if adding all the number's digits results in a number divisible by 3. This operation may optionally be repeated several times until a single digit is obtained. Try the number 279. The sum of the digits in that number is 18. The sum of the digits in the result is 9, so the number 279 is divisible by 3. Additionally, check the number 42. Adding its digits results in 6, so 42 is divisible by 3. The number 19 is not divisible by 3 because we can add the digits to get 10, and then we can add the digits again to get 1. Because 1 is not divisible by 3, neither is 19. The number 130 is not divisible by 3 because the digits sum to 4, and therefore 130 is not divisible by 3. Now let's cover divisibility by 4. A number is divisible by 4 if one of the following conditions is true. If the tens digit of the number we're testing is even, then the number is divisible by 4 just if the number ends in 0, 4, or 8. Instead, if the tens digit is odd, then the number is divisible by 4 just if the number ends in 2 or 6. Now let's look at the number 324. This number is divisible by 4 since the tens digit is even and the number ends in 4. Now let's look at the number 116. This number is divisible by 4 since the tens digit is odd and the number ends in 6. The number 8 is divisible by 4 since the tens digit is even, and the number ends in 8. In this case, the tens digit is 0. Now let's consider numbers which are not divisible by 4. The number 19 is not divisible by 4 since the tens digit is odd, and the number does not end in 2 or 6. The number 122 is not divisible by 4 since the tens digit is even, and the number doesn't end in 0, 4, or 8. Now let's cover divisibility by 5. A number is divisible by 5 if the number ends in 5 or 0 all the way on the right. Here's some examples of divisibility by 5. The number 35 is divisible by 5 since it ends in 5 or 0. The number 90 is divisible by 5 since it ends in 5 or 0. The number 1255 is divisible by 5 since it ends in 5 or 0. The number 23 is not divisible by 5 since it does not end in 5 or 0, all the way on the right. The number 86 is not divisible by 5 since it does not end in 5 or 0. Now let's cover divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. For speed, we try the divisibility test by 2 first. Let's see the example of 18. 18 is divisible by 6 because it ends in an even digit and the sum of its digits is a multiple of 3. The number of 72 is divisible by 6 because it ends in an even digit and the sum of its digits is a multiple of 3. The number 150 is divisible by 6 because it ends in an even digit and the sum of its digits is a multiple of 3. On the other hand, the number 77 is not divisible by 6 because it ends in an odd digit. So therefore it's not divisible by 2, and subsequently we can find it's not divisible by 6 because it's odd. The number 124 is not divisible by 6 because, even though it's even, the sum of its digits is not a multiple of 3. Now let's cover divisibility by 7. There are 2 steps to testing divisibility by 7. First, we count off the digits by blocks of 3 starting from the ones digit and insert alternating signs between them. Then perform the indicated arithmetic to complete step 1. Here are some examples of that step. Let's try the number 1,354,955 and see if it's divisible by 7. The first step is we break it into blocks of 3 digits starting from the rightmost digits, and we put in alternating plus and minus signs. This leads to 001 minus 354 plus 955, which is equal to 602. We pad with zeros on the left as shown. We then know that the original number is divisible by 7 if the resulting 3-digit number 602 is divisible by 7. Save the results for step 2. Now let's try the number 199,999,933. This can be broken into 3 blocks of 3 digits starting from the rightmost digits. This leads to 199 minus 999 plus 933, and the sum of this is 133. We then know that the original number is divisible by 7 if the resulting 3-digit number, 133, is divisible by 7. Save the next results for step 2. Now let's try the number 2,779. This can be broken into 2 blocks of 3 digits starting from the rightmost digits. This leads to 002 minus 779, which is minus 777. We know that the original number is divisible by 7 if the resulting 3-digit number, minus 777, is divisible by 7. We can feel free to drop the minus sign to get 777. Save this result for step 2. Now let's try the number 999,996. This can be broken into 3 blocks of 3 digits starting from the rightmost digits. This leads to 999 minus 0 plus 996, which is 1995. We can then break 1995 into 2 blocks of 3 digits each to get 1 minus 995, or minus 994. We then have 999,996 is divisible by 7 just as 994 is. Save the result for step 2. Now we repeat step 1 until we get a 1, 2, or 3-digit number, just like was done in example 4. Feel free to drop any minus signs at the end of the computation. Now we have step 2 for divisibility by 7. For step 2, we multiply the 100-digit by 2, the 10-digit by 3, and the 1-digit by 1, and then sum the products. Repeat this until we get a 1 or 2-digit number that can be checked manually if it is divisible by 7. We have 602 is divisible by 7 because we can add the products 2 times 6 plus 3 times 0 plus 1 times 2 to get 14. The number 14 is divisible by 7. Therefore, 602 is divisible by 7, and therefore the original number 1,354,955 is divisible by 7. We have 133 is divisible by 7 because we can sum the products 2 times 1 plus 3 times 3 plus 1 times 3, which is 14, a multiple of 7. Thus, 133 is divisible by 7, and therefore also the original number 199,999,933 is divisible by 7 as well. We have 777 is divisible by 7 because we can sum 2 times 7 plus 3 times 7 plus 1 times 7 to get 42. Therefore, 777 is divisible by 7, and also the original number 2,779 is divisible by 7. We have 994 is divisible by 7 because we can sum 2 times 9 plus 3 times 9 plus 1 times 4, which is 49, and 49 is a multiple of 7. Therefore, 994 is divisible by 7, and also the original number 999,996 is divisible by 7. Here's an example that doesn't work out the same way. In the number 1009, the alternating sum of 3-digit blocks is 1 minus 9, or minus 8. We can drop the minus sign to get just 8. We can then see that 8 is not divisible by 7, and thus 1009 is not divisible by 7. Now let's try 990,400,949. The alternating sum of 3-digit blocks is 990 minus 400 plus 949, or 1539. Form one additional sum of 3 repeating blocks to get 1 minus 539, or minus 538. Drop the minus sign. Perform the multiplication 2 times 5 plus 3 times 3 plus 1 times 8 to get 27, a number that is not divisible by 7, and therefore 990,400,949 is not divisible by 7. Now let's try 2013. The alternating sum of 3-digit blocks is 2 minus 13, or minus 11. Drop the minus sign to get 11. Perform the multiplication 2 times 0 plus 3 times 1 plus 1 times 1 to get 4. Thus, each of 4, 11, and 2013 are all not divisible by 7. Now let's cover divisibility by 8. A number is divisible by 8 if, upon throwing out the thousands place digits and higher order digits, the reduced 3-digit number is also divisible by 8. The number is reduced by multiplying the hundreds digit by 4, the tens digit by 2, and the ones digit by 1, and then forming the total. It is acceptable to reduce the number more than once. The number 2760 is a multiple of 8 because we can throw out the thousands digit and then perform the multiplication 4 times 7 plus 2 times 6 plus 1 times 0, which is 40. This is clearly divisible by 8. We can reduce again to get 4 times 0 plus 2 times 4 plus 1, which is 8. Therefore, 2760 is divisible by 8. The number 136136 is a multiple of 8 because we can throw out the thousand digit and all the digits to the left of the thousand digit, and then perform the multiplication 4 times 1 plus 2 times 3 plus 1 times 6, which is 16. This is clearly divisible by 8. The number 7,747,992 is a multiple of 8 because we can throw out the thousand digits and all the ones to the left of the thousand digit, and then perform the multiplication 4 times 9 plus 2 times 9 plus 1 times 2, which is 56. This is clearly divisible by 8. We can optionally reduce again to get 4 times 0 plus 2 times 5 plus 1 times 6, which is 16. 16 is divisible by 8, therefore the original number is divisible by 8. The number 4,444 is not a multiple of 8. We throw out the thousand digit, then we reduce 444 by performing the multiplication 4 times 4 plus 2 times 4 plus 1 times 4 to get 28. Reduce again to get 4 times 0 plus 2 times 2 plus 1 times 8 to get 12. We have 12 is not a multiple of 8, so 4,444 is not a multiple of 8. Now let's look at the number 109,996. We throw out the thousand digit and all the digits to the left of it. Then we reduce 996 by performing the multiplication 4 times 9 plus 2 times 9 plus 1 times 6 to get 60. Reduce again to get 4 times 0 plus 2 times 6 plus 1 times 0 to get 12. We have 12 is not a multiple of 8, so 109,996 is not a multiple of 8. Now let's look at the number 210,340. We throw out the thousands digit and all the digits to the left of it. Then we reduce 340 by performing the multiplication 4 times 3 plus 2 times 4 plus 1 times 0 to get 20. Reduce again to get 4 times 0 plus 2 times 2 plus 1 times 0 to get 4. We have 4 is not a multiple of 8, so that 210,340 is not a multiple of 8 either. Now let's look at divisibility by 9. A number is divisible by 9 if adding all the digits results in a number divisible by 9. This operation may optionally be repeated several times until a single digit is obtained. Try the number 279. The sum of the digits in that number is 18. The sum of the digits in the result is 9, so the number 279 is divisible by 9. Now let's try the number 4,419,999. The sum of the digits in that number is 45. The sum of the digits in the result is 9, so the number 4,419,999 is divisible by 9. Now let's try the number 234,567. The sum of the digits in that number is 27. The sum of the digits in the result is 9, so the number 234,567 is divisible by 9. Now let's look at the number 19. The sum of the digits of the number is 10. The sum of the digits in the result is 1, so the number of 19 is not divisible by 9. The number 130 is not divisible by 9 because the digits sum to 4, and 4 is not divisible by 9. The number 90,095 is not divisible by 9 because the digits sum to 23. The digits in that value sum to 5, and 5 is not divisible by 9. If you like this video, be sure to like, comment, and subscribe. Tune in for more STEM content.